Hey, my name is Maria Chzhen and I'm a grade 11 student attending Westdale Secondary School. For my science fair project, I did a multiple factor regression analysis of vegetation changes and land degradation in drylands. Land degradation is a process in which a biophysical environment is impacted by various anthropogenic processes acting on the land and is quantified with the normalized difference vegetation index, NDVI. Simply put, it is fertile land becoming unproductive, and it is a massive issue for the 2 billion people living on drylands. Up to 50 million people could be displaced just by 2030. Measuring the objective extent of each factor in vegetation has long been a tricky problem for climatologists because the methods of studying the issue vary, and specific objective metrics may not be possible to find. Nevertheless, determining the specific effect of each factor on vegetation levels is essential. It will close a vital knowledge gap, enable countries to efficiently allocate resources to deal with the cause of land degradation, and assess the implementation of relevant technologies. Thus, in my study, I set out to quantify the effect of various factors, including drought, precipitation, CO2 emissions, forest area, and electrical energy consumption on the vegetation cover of various regions using multiple factor regression, and identify steps that humans can take to increase the vegetation cover. The project was divided into several stages. First, I automated the process of bulk data import using the Python libraries requests and beautiful soup that web scraped and pulled data out of the HTML files. The program had extracted more than 67 gigabytes of monthly and annual geoscientific data from various sources, such as the National Oceanic and Atmospheric Administration's AVHRR, Terra Climate, Worldometer, and Our World in Data. The explored regions, the Middle East, Southern Asia, Australia, and South America, were chosen upon comparing their mean NDVI values from 1995 to 2015. A single AVHRR dataset contained around 26 million data entries. Values were recorded at every 20th of a degree, which means that each region had around 50,000 data points in a certain period. The data was processed with the NetCDF and CartoPy libraries, and initial map visualizations were created with Matplotlib. Then, I used Python's machine learning library, scikit-learn, to scale all features. Each feature was divided by the maximum value of the feature in a column. This step was necessary as it helped speed up the convergence of gradient descent necessary during multiple regression. After that, multiple regression was used to analyze the data. This statistical machine learning technique uses multiple independent variables to predict one dependent variable, an extension of one-factor linear regression that only uses one explanatory variable. The goal of the regression hypothesis, h theta, is to minimize the loss function j theta. By taking the partial derivative of the cost function, we get the gradient descent algorithm, which calculates the minimum of a function. A partial derivative simply holds all other variables constant. After, linear and asymptotic regression temporal models were generated for each feature and then compared by their R-squared values. Finally, prediction intervals, which are ranges of values that predict the value of a new observation based on the existing model, were generated for each graph. The results have shown that the most substantial changes in NDVI over 20 years, from 1995 to 2015, were recorded in the Middle East, Australia, and Southern Asia. The Middle East experienced an asymptotic change in NDVI, PDSI, which measured drought, electrical energy consumption, and CO2. Australia's NDVI and electrical energy consumption have changed in a linear trend and are inversely proportional to each other. Its CO2 emissions have increased in an asymptotic trend, and its forest area has increased at a stable rate from 2011 to 2015. South America has undergone few changes in NDVI, yet it has experienced an asymptotic increase in CO2 emissions and electrical energy consumption, and an asymptotic decrease in the forest area. Despite the linear growth in forest area, Southern Asia's NDVI has decreased in a linear trend, partly due to the asymptotic increase in electrical energy consumption and CO2. According to the multiple factor regression algorithm results, the effect of each factor on the changes in NDVI varied for different regions, just as predicted. Multiple regression could not fully explain the phenomena happening in Southern Asia, as the effect of some variables could have negated the effects of others. For example, the growth of CO2 may have nullified the active afforestation efforts. All regression models showed that the effects of electrical energy and CO2 emissions played the most prominent roles in NDVI scores. Electrical energy consumption played the most notable role in Middle East and Australia, while CO2 emissions were the most substantial factors in South America. So how can governments deal with the growing problem of land degradation? Iran is one of the most energy-intensive and inefficient countries in the Middle East because of its vast energy subsidies. The country is the largest exporter of natural gas globally and has one of the most massive oil reserves, which fits with the facts discovered in the study. In 2019, hydropower generated 9% of the country's electricity. Iran has 588 dams. However, despite hydropower being a better alternative for natural gas, it is not optimal. The effects of dam building are reflected in the increasing PDSI values, which in turn lead to smaller vegetation cover. Dams disrupt the seasonal flooding patterns, which leads to lower soil fertility and higher unsustainable use of fertilizers. The best solution would be to generate power using solar and wind energy. Considering its location, the country could generate up to 9 million megawatt hours of energy per day. Australia's primary energy consumption sources are coal, oil, and gas. Despite its afforestation efforts, its vegetation cover has decreased linearly. The decrease in NDVI could also be attributed to climatic variability, as Australia's periods of drought are punctuated with extreme precipitation, which creates suboptimal vegetation conditions. Australia can focus on generating solar power to improve the situation, as it receives an average of 265 days of clear sun a year. South America is already dependent on hydropower, a renewable energy source, which explains the lack of net change in NDVI. Like Australia and Southern Asia, climate variability seems to play a significant role in the drastic changes in PDSI and precipitation. In conclusion, I have identified the more fundamental causes of the decrease in vegetation cover and have shown which actions governments can take to prevent desertification and, potentially, save millions of people from losing their homes. My study is unique in its computational and statistical approach to the problem. Multiple regression analysis is a novel approach to desertification and has revealed fascinating and valuable information about the issue. The project is at the junction of three sciences: statistics, computer science, and ecology, which modern environmental science is all about. Working on the project has been a delightful experience, and I will undoubtedly continue studying and improving in this field and topic. Thank you for listening.